We are going to calculate the thermal conductivity of the bad conductor using least disk experiment. Here, aim is to find the coefficient of thermal conductivity of the bad conductor by least disk method. The bad conductor can be taken as a cardboard. Apparatus required: the least disk arrangement, bad conductor. Here cardboard is taken, 2 thermometers, a stop clock, steam boiler, screw gauge, vernier caliper, and a graph sheet. The formula is K, the coefficient of thermal conductivity of a bad conductor, is equal to S, the mass of the disc, S, specific heat capacity of the disc, D, the thickness of the cardboard, d theta by dt around theta 2, that is rate of cooling, difference in temperature with respect to time around the steady state temperature of the least disk, and then R plus 2h. R is the radius of the metal disc, h is the thickness of the metal disc, divided by pi r square theta 1 minus theta 2. Theta 1 is steady state temperature of steam chamber, theta 2 is steady state temperature of least disk, and then 2r plus 2h. The unit is watt meter inverse Kelvin inverse. Let us move on to the procedure. This is the least disk arrangement. It consists of a heating arrangement, a hot plate or a coil stove, over which there is a steam boiler. It is half filled with water. And A, the steam chamber, B is the least disk. The stand arrangement is made, so then A and B is suspended in the stand and thread arrangement. The outlet of the steam boiler and the inlet of the steam chamber is connected by means of a rubber tube. Provisions are made in the steam chamber and the least disk to insert thermometers. Now, when the source is switched on, water boils at 100 degrees Celsius, steam escapes through the rubber tube, and then it gets collected in the steam chamber. Now, the temperature in the thermometer 1, which is inserted in the steam chamber A, is increasing. Then the heat is given to the metal disc B. Now, a cardboard for which we are going to find the thermal conductivity is inserted in between A and B before starting the experiment. Now, the temperature at A will be falling onto the bad conductor, and then it is moving towards the metal disc. After a while, we can see the thermometer T1 will show a steady state temperature called as theta 1. Theta 1 is noted, and I am taking it as 100 degrees Celsius. So all the 100 degrees Celsius focusing on to the bad conductor. Being a bad conductor, it could not supply all the 100 degrees Celsius. The thermometer T2 will show temperature after a while. It is taken as the steady state temperature. In this regard, it is found to be 60 degrees Celsius. So steady state temperature is the thermometer will have mercury or spirit, that is alcohol level. It will be increasing with increase in temperature, and after a particular point there won't be any further movement in this mercury level. Then this is taken as the steady state temperature of steam chamber or the metal disc respectively. So in this experiment we have found theta 1 as 100 degrees Celsius, theta 2 as 60 degrees Celsius. Now we have a tabular column here, temperature in degrees Celsius, time in seconds. The theta 2 is written at the 6th position, and then at the first place theta 2 plus 5 degrees Celsius is written. Then 65, 64, 63, 62, 61, 60 we have theta 2 here, and then 59, 58, 57, 56, 55 till theta 2 minus 5 degrees Celsius. For every 1 degree decrease in temperature is written here. Then in the experimental arrangement we are removing the bad conductor which is kept in between A and B. Due to metal-metal contact, A is a metal, B is also made of the same metal contact. The temperature shown by the thermometer T2 will be increasing. When it reaches theta 2 plus 10 degrees Celsius, then the heating source is switched off. The steam chamber is removed. So then only the stand, the lees disc along with the twine arrangement will be suspended with the thermometer T2 showing the temperature theta 2 plus 10 degrees Celsius, or it is decreasing to theta 2 plus 9 degrees Celsius. Now stop clock is taken. When the thermometer comes down to exactly theta 2 plus 5 degrees Celsius. In this particular experiment, theta 2 plus 5 degrees Celsius is 65 because theta 2 is 60 degrees Celsius. Theta 1 is 100 degrees Celsius. So this theta 2 is very important. When the temperature shown by the thermometer is exactly coming down to theta 2 plus 5 degrees Celsius, the stop clock is started. Then it shows 0 second. Continuously for every 1 degree decrease in temperature, just like 65, 64, 63 in that way, the time is noted for every 1 degree fall in temperature in the stop clock. The condition is we should not disturb the setup, experimental setup, as well as we should not stop the stop clock. Continuously the time should be increasing with the decrease in 1 degree Celsius of the metal disc. We found that this is the time taken for every 1 degree fall in temperature. If it is example, if it shows 1 minute and 45 seconds, we have converted that in seconds fully. 1 minute is 60 seconds, 45 plus 45 we have got 105 seconds. In that way the temperature versus second, that is time, is taken, and a graph sheet is plotted. Along the x-axis the time is taken. Look at the time. 0 second is the minimum time taken. 565 is the maximum. So I am writing for every 50 degree I have plotted the graph here, and in similar way here minimum is 55 I have taken, and then 65 is the maximum. So every 1 degree is noted along the y-axis. Then a graph is plotted. For example, at 65, 0 second. So 65, 0 second is taken. 64, 40 second. 64 I have noted 40 because here 1, 2, 3, 4, 5. So 50 degree, that is 50 second, is taken for 5 lines. So one line is 50 by 5. It is 50 second. Therefore it is 10 second. So 40 is the fourth line I have plotted here. And then 63, 105. It is 1 and 105 is here. 62, 158. 62 is, this is 150. 155 here around, here I have taken. 61 is 204, 61, 204. 60, 263, it is 250, 260, 263 I have taken. So this point and the circle denotes around this point somewhere this second, that is time, is lying. And then 59 is 306. 59, it is 306. 58, 378. This is 350, 360, 370, 378. 57, 445. So 400, it is 445. And then 56, 503. In that way I am drawing. So plot the graph exactly and then connect all the lines. You will get a graph for theta versus time. That is theta along the y-axis and time along the x-axis. Our point is d theta by dt in the formula, difference in temperature or rate of falling. Difference in temperature with respect to time around theta 2. Where is your theta 2? This is 60 degrees Celsius is our theta 2. Theta 2 plus 1 degree Celsius, theta 2 minus 1 degree Celsius is taken and we need to find the slope. The difference between the temperature. So if it is 60, theta 2 plus 1 is 61, theta 2 minus 1 is 59. So the difference between these two is 2 degrees Celsius. Similar way dt, difference in time. So here we have plotted for 306 and here for 59 is 306 and then here it is 204. So 204. So 306 minus 204, it is 102 second. So d theta by dt is difference in temperature is 2 degrees Celsius. 2 degrees Celsius divided by difference in time is 102 second. So we have got, use your calculator, 2 divided by 102 will get 0.0196 degrees Celsius per second. And then we are going for finding the radius of the metal disc, least disc, using vernier caliper. We found that it is 5.572 into 10 power minus 2 meter. It is in centimeter scale. And then thickness of the cardboard using screw gauge. Here the error corrections are clearly found and then the thickness of the cardboard is 4.428 millimeter or 4.428 into 10 power minus 3 meter. It is D and this is R. Thickness of the metal disc is determined using screw gauge. It is H and it is found to be 10.342. In the calculation part, we are going to fill all the observed readings. The mass of the metal disc will be provided. So what type of material is given? It will be provided in the manual itself. 850 grams, it is converted into kg. Specific heat capacity of the disc, S, is 385 joule per kg per Kelvin. And then d theta by dt around theta 2. So rate of cooling around theta 2, we found it is 0.0196, divided by 102. 2 degrees Celsius, 102 second. Steady state temperature of steam chamber, theta 1 is 100 degrees Celsius. Similarly, the constant temperature shown by the metal disc is 60 degrees Celsius, that is theta 2. The radius of the metal disc is here 5.572 into 10 power minus 2 meter. H is 10.342 into 10 power minus 3 meter. And then thickness of the cardboard is 4.428. 4.428 428 into 10 power minus 3 meter. Now we are going to do the calculation in the formula. The thermal conductivity of the bad conductor is M. M is 850 grams. This is M. S is 385 joule per kg per Kelvin. And then D is 4.428 into 10 power minus 3. This is D. D theta by dt is 0.0196. This is d theta by dt around theta 2. Then into R plus 2H. What is R? 5.572 into 10 power minus 2 plus 2 into H is 10.342 into 10 power minus 3. Then divided by pi 3.14. This is R and this is H into pi R square 5.572 square into 10 power minus 2 the whole square. Pi R square. Theta 1 minus theta 2. Theta 1 is 100 minus theta 2 is 60 degrees Celsius. This is theta 1. This is theta 2 into 2R plus 2H. In this 2R plus 2H, I am going to take 2 as a common term. I am going to write R plus H. 2 into R is 5.572 into 10 power minus 2 plus H is 10.342 into 10 power minus 3. R plus H. If you want to calculate this calculation easily, your first work is find R plus 2H. That is, this particular value should be taken. In your calculator, use 5.572 into 10 power minus 2 and then plus, you put a bracket, open bracket, 2 into 10.342 into 10 power minus 3, close it with a single bracket. That is R plus 2H. Then you will get 0.0764. Similarly, you find the value for R plus H. That is R plus H. You will get 0.06606. Now substitute all the values in the calculator right from the beginning, double bracket. Substitute all the numerator. Instead of this, you are going to substitute this. Close it with a single bracket here, divided by single open bracket. Substitute all the values, and then 100 minus 60 can be taken as 40 here. Instead of this, you are going to substitute this. Close it with double bracket here. You will get 0.04189. So the thermal conductivity of the cardboard, given cardboard, is watt per meter inverse Kelvin inverse. So this is the result. The thermal conductivity of the bad conductor using least disk arrangement is determined as 0.04189 watt meter inverse Kelvin inverse.